Topic 3, Class 3. In this class we're going to look at graphs of some common engineering functions. We're not going to look at trigonometrical ones here. We're going to look at parabolas, cubics and absolute value graphs. If we're looking at a quadratic, then we've got two choices. Remember, a quadratic is something that looks like ax squared plus bx plus c is equal to y or z or something. We can either have a positively shaped parabola, it doesn't need to go through the origin, or we can have a negatively shaped one. Now, if it's positive, then the coefficient of the x squared is positive. If we have a negative, then the coefficient of the x squared is negative. That's how we tell. At this stage, we have to use a reasonable number of clues to be able to sketch this particular parabola. So start off by drawing your axes. And the first thing we know for certain is that it's going to cut the y-axis at -2. What we do know is that we know that there's a rule, a formula for finding the coordinates of the vertex. The vertex is the turning point. Later on we'll find a different way of doing it. So that's the x value, and then we can find the k value, so that's the x value, and that's the y value of the vertex. So k is equal to 4ac minus b squared over 4a. So if we use a, b and c, and then we can find that h is equal to -1/6 and that k is equal to -25/12. We can mark that on, so when x is -6, so there's 1, so it's about there, that's 2, so it's a little bit below 2, so the vertex is going to be about there. Now, later on, we'll be able to solve where it cuts the x-axis. It would cut the x-axis, where y is equal to 0, but we're not quite at the position of being able to solve where 3x squared plus x minus 2 is equal to 0. So at this stage, we can just guess. But the bottom point is not on the axis. The bottom point is down here at -1/6, -25/2. So we're just going to do a quick sketch like that. And it's going to go up like that. At this stage, that's all we know how to do. We've looked at quadratics. Now we're going to look at a cubic. You can get one that goes through the origin, which would just be like that. That would be just a basic y equals x cubed. We could get one that was put in a slightly different place, where it would say up to. That would be y equals x cubed plus 2. And later on we'll look at other ones where we can find where it cuts the x-axis. Now this one on the right hand side is not a cubic, it's an oscillating one, and we'll look at later on that we'll be able to work out what these ones are. But it's a cos curve, like that. So there are lots of different shaped graphs that we need to be able to recognise. The absolute value of a number is just the distance from that number to the origin, but we need to define it officially. And it has two parts to it, and we say that it's equal to x if the bit in the brackets, it doesn't always have to be just x, but the expression that's in there is positive and it equals the opposite of itself if what's in there is negative. This is an absolute value curve. It's a negative one, which means it's going to be that typical shape. And the fact that it's x plus 2 and plus 11 means that the vertex, which was at 0, 0, is going to move to the left by 2 units and up by 11. So it was at 0, 0. Now there's been a translation of the vertex up to the point -2, 11. To find the intercepts, first up we need to find when x is equal to 0. So when x is equal to 0, we have 0, well, don't forget that negative sign, plus 2 plus 11. So it's 2, but it's -2 plus 11, so it's 9. We then need to find where it cuts the x-axis. We need to find these two numbers down here. Okay, we need to find when y is equal to 0. So we need to find that -x plus 2 plus 11 is equal to 0. So that tells us, we rearrange that x plus 2 is equal to 11. Because if we put that over there, it becomes negative, and then we've got that one and that one, which will give us that. Now, by the definition, we've got two parts. We've got part A. Part A says that, let's take the first part of the definition, so that we need the version where if x plus 2 is positive, then the absolute value of it is equal to x plus 2. So that means now we're solving x plus 2 equals 11, so that x is equal to 9, which is the point on the right hand side. Then we take the second part of the definition that says if x plus 2 is negative, then absolute value of x plus 2 is equal to the opposite of x plus 2. So now we have -x plus 2 equals 11. So x plus 2 equals -11. So x equals -13. So this point here is -13. Now we just join it up. I've already joined it up, but we just join it up with a V-shaped curve. The standard process for sketching curves, and notice we are now sketching curves. We are not plotting them as we were in the first class. First up, you look at the equation and you decide on the shape. Look at number 6 there. It says y equals x squared minus 4. That's a parabola. So the shape of a parabola is either a smile or a frown. And in this case, it's a positive one, so it's going to be a smile. We'd need to choose a scale for the axis. And that means we need to look a little bit sensibly at what numbers we put on the x-axis or the y-axis. If x is 2, x squared is going to be 4. If x is 4, 16, 16 minus 4. So maybe if we go up to about 12. So 2, 4, 6, 8, 10, 12. Okay, find the x-intercept. So when x is equal to 0, y is equal to -4. Label it. When y is equal to 0, then x squared minus 4 equals 0. So x squared equals 4, x equals plus or minus 2. And it's clearly symmetric, so now we just have to join it up with a nice curve like that. Don't forget, now you're going to label it. That was an easy one to draw, but it's the process that we need to look at. The 5 steps. All of that information has to be on a graph when you're drawing it.